Hello everyone, my name is Simran Khanuja. I'm a first-year PhD student at Carnegie Mellon University, and today I'm very excited to talk about our work on developing a framework to evaluate the diversity, equity, and inclusion of NLP technology. This work was done with my amazing co-authors Sebastian and Partha when I was at Google Research India. So, what prompted us to develop this framework in the first place? When we were choosing amongst multilingual models to use for a certain subset of low-resource languages, we observed that even the SOTA model on a prominent multilingual leaderboard is just not good enough. Even though its average accuracy is better than, say, the second best model, it only provides for marginal improvements in most languages. So can we conclude that the SOTA model is better than the second best? Well, if we look at it purely from the perspective of its position on the multilingual leaderboard, we would say yes. However, I raise three questions here. Does it improve the diversity with respect to the population it supports? No. Does it improve the equity across languages? No. And does it improve the inclusivity across users? No. In fact, it's larger than the second best. So why not, right? Why, as a community, are we not trying to make improvements along these axes? Is performance the only thing that we need to get? Well, I believe, and we believe, that this is largely an artifact of the lack of incentives. The leaderboard design incentivizes model builders to simply improve average accuracies across languages. Now, why is DEI for technology important, you may ask? To build these three pillars in our framework, we borrow from the social construct of equal representation, which focuses on diversity, equity, and inclusion. In our context, we believe that as technology makers, we hold the responsibility to serve all of the world's population to the best of our capabilities. We also should reduce propagation of bias through the technology we serve, and we must also serve all users equally, regardless of their status or accessibility. Now, what would happen if, as a community, we are not trying to incentivize these three? If we don't incentivize diversity, we will simply keep improving performance for languages that we have data for, like you saw in the previous graph in the previous slide. If we don't incentivize equity, we will not try to make any modeling improvements to gain equitable performance despite imbalanced data. And if we don't incentivize inclusion, our models will keep scaling up and become less and less accessible in pursuit of higher accuracies. So the important question here then is, how do we measure all of these three in our framework? To measure diversity, we borrow from peer-reviewed work by Blasi et al., which proposes to incorporate demand with performance to measure the utility of a system. For equity, we unfortunately do not have any peer-reviewed work in the NLP community, and we propose to use the Gini coefficient here, which is a widely used measure of statistical dispersion in economics. And to measure inclusion, we again build upon peer-reviewed work of Ma et al., which incorporates in efficiency metrics in model performance. So now let's define each of these factors, right? Diversity. Diversity is composed of two main aspects. So the first is utility and the second is demand. And the global metric is a composition of the two. Utility is the performance of a model normalized by the best possible performance afforded by the task. Demand is basically a metric which helps capture the speaker population. So it allows for a demographic or a linguistic perspective to speaker population. Under the former, demand is directly proportional to the number of speakers, and under the latter, we assume that demand across languages is identical. So tau helps us parameterize any combination in between. And the global metric is composed of utility and demand. So we have to make a decision for what tau we use, and given our user-centric aim to measure benefit for all speakers, we employ the demographic notion where our demand is directly proportional to the number of speakers of that language. For equity, we propose to use the Gini coefficient. Why don't we stick to standard measures of statistical dispersion like standard deviation or calculating range? This is because they are scale dependent, they are unbounded, and they are highly sensitive to outliers, which makes them not very good measures for distributions that are not normal. And in economics, measuring statistical inequalities is really important for multiple applications, for example, to quantify disparity in income distributions. And the choice of income inequality indicator is very important because it has implications in measuring health, state-level mortality, etc. So there's been extensive study in good sparsity measures in economics. Here again, we borrow from a peer-reviewed work which kind of proves that the Gini coefficient is the only measure which has 6 desirable attributes of sparsity measures, and they compared like a variety of alternatives and proved the Gini coefficient to be the best. We also found it to work extremely well in our setting, so we use the Gini coefficient to measure equity. A Gini coefficient of 0 means that all languages are served equally, and a Gini coefficient of 1 means that one language has all the performance allocated to it, and the rest of the languages have 0 performance. Inclusion. So for inclusion, we incorporate efficiency into model performance based on 2 key factors. So one is throughput, which is the number of instances you can process per second, and the second is memory saved. To get the final efficiency score, in our framework, we use default weights of giving 50% weightage to the actual performance, like F1 accuracy, and 25-25 each to throughput and memory. But these can definitely be adjusted based on user constraints in practice to get a good efficiency score, good efficiency comparison across models. So once we developed this framework, we wanted to apply it to a particular setting. And we do a case study for 22 Indian languages. So I will briefly describe my experimental setup here. We have 22 scheduled languages spoken by 97% of the population. We select 4 tasks from the extreme benchmark. The 4 tasks are NER, power of speech tagging, NLI, and question answering. For models, we basically wanted to select models based on 2 key factors. So one is we wanted to compare like general versus region-specific models, because we have a lot of region-specific models for Indian languages. And we also wanted to select smaller and larger models so that we can compare for model efficiency. So these are the models we have in our study. And another consideration is these are pre-trained models. So what do you fine-tune this on? A common language which has been used for fine-tuning is English, because there is label data across all tasks for English, but it has been shown that it is a suboptimal transfer language or pivot language for most languages which are pretty distant. So we also fine-tune these models on Hindi, because Hindi is a language which 15 out of 22 languages have the same language family as Hindi, and we have label data for tasks, and it's also the language with the highest speaker population in India, so it's future-proof with respect to annotation. So let's look at some results here. So as you can see, the differences in average performance definitely do not reflect differences in DEI. So here on the right, I am visualizing performances for one task, say NER, and I observe that the average F1 is slightly, so Mural Large, which is the region-specific large model, has a higher average F1 across all tasks. But if you look at the equity measure, for example, it is consistent. It is the same across all models. And that and inclusion, from an inclusion perspective, we observe that region-specific smaller models are much better. So, an important and surprising finding was that equity is consistent, which was also reflected in our first graph. If you remember, it's like a reflection of what has been happening in the past. And that's because people are not making an effort to improve the deltas between languages, because the performances are a reflection of the pre-training data. So unless we make some modeling changes actively to strive for this equity, we will not be making any progress here. So how can we improve the DEI of pre-trained models, right? We have highlighted that there is a huge gap that we need to fill, but how do we improve this? Before talking about the improvement, why do these disparities exist? Well, like I said, model performances mostly reflect the amount of raw data used in pre-training, and it is a highly ambitious undertaking to create equitable data resources for all languages in the world. At least in our study, we try to see what we can do with models that are already pre-trained in the fine-tuning stage, so that we can optimally leverage a data annotation budget to fine-tune models which maximizes DEI. So we propose a fully computational approach where we empirically estimate performance of target languages when fine-tuned on a source language. And then at each step, when we want to do data selection, we allocate a sample to the source language, which confers the highest marginal gain with respect to any of the three metrics that we want to optimize for: diversity, equity, or inclusion, to all target languages. More details can be found in our paper, but for time constraints, I couldn't go more into this. We also find that our performance is better than or equal to an egalitarian distribution across budgets. Now, the most important question is, how can our community help improve DEI of NLP technology? We lay out a few proposals in our work, but it is definitely far from complete. And if we want to improve DEI of NLP technology for all 7,000 languages, we need our community to make data and modeling efforts. So we need to build representative evaluation sets, which is key to even measuring DEI. And we should collect small amounts of data across many languages for fine-tuning, because that's what we observe maximizes marginal gain. We must try to collect data at grassroots level so that we can capture culturally relevant phenomenon. With regards to model building, we can try to make region-specific choices both in pre-training and fine-tuning. Like we observe, fine-tuning on Hindi is much better than fine-tuning on English for Indian languages. And localizing the problem also helps us incorporate linguistic expertise. But we must be wary of excessive fragmentation, as it may lead to higher maintenance costs. So this was our work, and I'm very excited. We have already collaborated with a few people to incorporate these measures into their leaderboard, and more on that will be coming soon. So thanks, and have a great conference.